there, 7th grade. I miss seeing your faces, and I hope you're all doing well. I wanted to just touch base about lessons 9.19.A, and then I'm also going to make a video for 19.B as well that I'm going to put up for you guys. 19A is all about the different cycles that occur naturally in our world, okay? And these cycles replenish different things to our environment. The first one being the water cycle. I know you've heard of the water cycle before. I've included some YouTube videos at the bottom. The Go Noodle song is a favorite of some, not of everyone, but if you want to watch the video and dance along, you can. Essentially, the water cycle is just the cycle of how water continuously is available and supplied to our environment. And so it starts, if this is found on pages 398 and 399 in your textbook. Sorry, I should have grabbed that first. But it starts, you can start anywhere along this cycle, okay? We're going to start with the number 1 where it has in our textbook evaporation, okay? Water from puddles, from lakes, from streams, from rivers, it evaporates. And as it does, it turns to what we call water vapor in our atmosphere. And that water vapor then can collect, and it collects into clouds, and we call that condensation. Okay, so the water vapor cools, and as it cools and collects, then it can start to precipitate or fall back down to the earth. Now, when it precipitates down, that it can do it in multiple ways: rain, sleet, snow. The rain, essentially the water falls back down and replenishes the water into our lakes and streams and rivers. Now, think about that for a second. Can you evaporate salt? Does the salt go up into the air as well? No, it doesn't. Okay, salt cannot evaporate. So what does that tell you about our oceans? Are they more salty or less salty than when God first created them? They're going to be more salty, right? Because the salt can't evaporate. And so the water, as it goes up, will leave behind the salt, and the water will go up, and then when it comes back down, it'll actually collect more salt as it comes down through the lakes and streams and picks up the salt from the rocks and whatnot, and then it will end up in the oceans where we have some more salt, okay? This cycle is really important because it keeps water fresh and moving throughout our world, okay? Another cycle that we talked about, or that you read about, was the carbon-oxygen cycle. This has to do with us expelling carbon dioxide and also breathing in oxygen. Okay, it's not just about us though, right? Because plants need carbon dioxide and expel oxygen. So plants need that delicate balance as well. And so let's talk about how that carbon-oxygen cycle works, okay? Plants are producers, right? They photosynthesize, and in order to photosynthesize, they need to have carbon dioxide. So in the air that we breathe, there is carbon dioxide molecules. And so the carbon dioxide gets absorbed by the plants. They convert it then into oxygen and glucose, and they release that oxygen back into the atmosphere. You see that there are, how do we get so that's how we get the oxygen back. How do we get the carbon dioxide? Well, there's a couple different ways we get the carbon dioxide. One of them is really easy. We breathe it out, right? Our bodies convert oxygen and they use it up, and we get carbon dioxide, and then we breathe that out, okay? Another way, so that's a byproduct of cellular respiration. Another way we release carbon dioxide is through fossil fuels, okay? The burning of fossil fuels releases carbon dioxide into the atmosphere. And another way is from dead and decaying animals that die. They also release carbon dioxide back into the atmosphere. And so it's a delicate balance that we want to keep balanced so that our carbon and oxygen cycle is at the right balance for life, okay? And it's really kind of cool that God would have designed these cycles just to naturally occur in the world, right? God knew that we were going to need oxygen, and he knew that plants were going to need carbon dioxide, and so he set up this cycle that is just works beautifully, okay? The last one is the nitrogen cycle. This is a little bit different. In the air we breathe, there is not just oxygen, right? When we think of the air we breathe, we just think of oxygen. Oxygen is actually a small fraction of what's actually in the air. The majority of air, like 78 or so percent is, let me double check that number real quick. Yeah, 78% of the air is actually nitrogen. And so nitrogen is an important part. We need it to make up our DNA, we need it to make proteins, etc. But the problem is nitrogen, we can't use nitrogen gas, and plants can't use nitrogen gas. They need it to be the actual nitrogen molecule. So how do we get it from a gas to a molecule? And that's what the nitrogen cycle is all about. Okay, there's a couple steps that you're going to go through that you're going to learn about: conversion, integration, decay, and reconversion. Okay, and I included a video from the Amoeba Sisters to help you to kind of understand how, oh no, sorry, not Amoeba Sisters, it was Brain Pop, to understand how these different processes work. So bacteria plays a really important role in this. Our nitrogen can't get fixed without it. So essentially they add, so nitrogen comes into the, near where the bacteria is, and the bacteria then attaches different things to it, whether it's oxygen or hydrogen, and then the different bacteria will do the different things to the nitrogen until you've got like a nitrogen molecule that can be used by the plant. Another thing a bacteria will do is they'll actually reconvert it back into nitrogen gas. So there's one bacteria that will like literally rob the nitrogen gas of its molecules and turn it, so then that turns it just back into a gas instead of it being a molecule. Okay, so like it'll take away the oxygen or the hydrogen that's on it. So this is really important because plants and people, we can't use the nitrogen gas. We need the nitrogen to be turned into a molecule. If it's not turned into a molecule, then we can't use it, and we need it to build those proteins. One of the main things your body does is to build proteins.